No other questions. I will make one comment on one problem that could freak you out pretty easily. I don't know which number it is, but it's you basically have to prove a reduction formula.
It's 54.
Yeah. And just to give you a little clue, anytime, even if they don't, damn, if you're doing a problem and you're like, I don't know what to do this problem, go get help, whatever. The very first thing you do is look at the examples, right? I need you to understand, are any of you going much further with math? Anybody even thinking about a math major? Some of you guys are like, I was before I did your classes last week. No, I'm like, screw. Some of you guys, okay. Love the fact that you still have a book that gives you examples. Oh, holy crap. So you get up to a certain level, and you get this tiny little book. It still costs $200. And you crack it open, and there's concept problems. And you're like, wait a minute. And you look back, no examples, right? Just concepts and then problems. So my God, if you're not looking at the examples, I don't understand you. That one specifically calls out example 6. Look at example 6, yes? That one is a problem. When I was telling somebody that had asked me some questions earlier, if that's the only problem that's giving you trouble, you're doing great. That's a problem that's supposed to push you a little bit. But if you look at the example, it kind of steps you through what you might try to do. Okay. Just keep that in mind when you get to number 54 in 7-1. Okay. Anything else from homework? I'm noticing, I know the WebAssign people, not many have started or gotten very far in 7-1 the last time I looked. And you don't have to have. Don't take that as me saying something bad. But you desperately have to get in there, especially with that quiz coming up. Oh, shit. All right, if there's no other questions from homework, I'm just going, yeah. You good? You have a question? Yeah, what's up? Which one, sorry? Do you have homework? Oh, okay. Yeah, there's a homework sheet up in Canvas, and it's got the pacing of the course. It's got all the assignments for the entire semester. And you can either do the homework on WebAssign, or you can do it out of the book, pencil, paper. Yeah, you can get an ebook and do it pencil, paper still. Everybody understand? So you can certainly rent an ebook, do pencil, paper. That's beautiful, right? Yes?
It's due next Wednesday, right?
Homework is officially due the day of the test. Yes? So, at the top of my head, I can't remember what the first test day is.
March 1st.
Yeah. But, dear God, don't give it all to me on the day of the test, right? Give it to me as you get done. Somebody's already turned some in. I love it. So when you get section 7-1 done, just give it to me. I will then have time to put notes on it and kind of grade it a bit and then give it back. Okay. Yes?
Can it be pen and paper?
If you use pen, you better not make any mistakes. That's all I gotta say. I hate this scratching the shit out. If you have an actual eraser that can erase pen, well then don't use pen. Okay. Unless you don't make any mistakes. Yeah. Okay. No pressure. Yes?
There was one question on what I was stuck on. It was, I think it was like the integral of x to the 4 times the square root of 4 plus x squared.
Maybe it's x cubed?
Yeah, it was the one that I was asking about.
Like that?
Yeah.
Okay. This is kind of nifty. Let me see if anybody can see this. What do you wish this power was to make it like really like a Calc 1 problem? First power. If that was a first power, what method could I use? U sub. Kick ass. Unfortunately, that's not a first power, and you're not allowed to just substitute your own reality. So you have to deal with that shit. But the beautiful thing is, x cubed has an x in it. So real quick, if you wanted this to be u sub, what would you let u equal?
4 plus x.
And then what would du be? So if you broke this up, right? you see that?
Yeah.
Is that cool? And you put the little 1/2, you can put the little chew, like your Indiana Jones and the thing. Little gold statue and the, no? Okay. This is du, this is square root of u. Well, what the shit is that? Well, your very first statement tells you what it is. What's x squared? Can you solve for x squared? U minus 4, that kicks so much ass. That's too beautiful to believe, right? So, some teachers might even do this using by parts, which is incredibly silly because it's just a u sub with one little extra step, right? I really want you guys to fully understand the flexibility of u sub. You just got to replace all the x shit with u shit. So, anytime you let u equal some function of x and you can solve for x or something, that could be another substitution to use. So if it would have been x to the 4th, which thankfully I know it wasn't, that would have been a lot worse. That would have possibly been something from 7.3, if I'm remembering my sections correctly. I think so, yeah. But thankfully it wasn't, so you can do this. So watch this. There was another problem that's something like almost the same thing, I think. Do you see how that's going to work the exact same way for pretty much the exact same reason? It doesn't look the same. It's not the same kind of function exactly, but it's got the inside. Its derivative is one of these, but u would be related to r squared. You guys see how that's the same idea? Yeah. Okay. Okay. I love it. Anything else from homework? Okay. And again, anytime before I've like launched into lecture or whatever, I ask if there's any questions. You guys can ask questions like, hey, do you know a way to remember the identities? Do you know the trig identities? Any of that kind of stuff, right? And I've got to monitor how much time I want to spend on that. You guys can always come to the Math Study Center, get some more ideas. Anyway. Okay. And also, if there's any problems that I sort of don't finish, just ask, hey, can you finish that? That's fine, right? Sometimes I just kind of get to a point, I'm like, okay, you guys go from there, and you're like, I don't know how to go from there. Say that. That's okay. Okay. So I think, if there's no other questions, I think last time I gave out this worksheet, so. This one on the top had that blue box with the inverse trig derivatives in it. Anybody else need that? Okay. So we kind of started doing some stuff. Let me see. So for example, just to recall what's happening, what is it about this problem that kind of tells me what to do?
Odd.
Yeah, when you have sine and cosine, you're looking for the odd power. Which one has the odd? If they both have the odd, you can actually do either one. So what is the fact that the sine has an odd power? What does that tell me I'm going to do?
Separated.
Yeah, so this one, I can pull a sine off of that. So I know I want du to be this, which pretty much tells me what I want u to be, right? Okay. And again, I don't care, there's going to be a negative in there, who cares? We can make a negative show up easy. Okay, so that's why on that paper with the little blue box, if you look at the sine cosine, it's all about which power is odd. If they're both odd, you could choose either one. You guys kind of with me? A little bit? Okay. So this is really just a u sub. It's just written in a way that we can kind of formalize differently, but it really is just u sub. So what are you going to let u equal here? I really want you guys cool. This is going to be du. U's got to be cosine. So then du is actually going to be
Sine, negative sine.
negative sign. So then I just need a negative. Negative. Okay. That's almost too nice to believe. And sine and cosine are easy relatively to almost everything. They're pretty easy. Okay, so then I get negative integral. U is cosine, so this will be u squared. This is going to be the one that sucks a bit. But does somebody know how I can rewrite this? I want it in terms of cosine. Does that make sense? Because I need it to come out to be in terms of u, and u is cosine, so I need it in terms of cosine. How do I get this to be in terms of cosine? Yes?
It was sine squared times sine squared.
Yes. So this is sine squared squared. Let me see, and this is du. I like it. So this will be 1 minus cosine squared. So 1 minus u squared. Is that cool? Because u is cosine. And then this is just kind of a busy work problem, to be honest. You gotta FOIL this out and distribute this graph. It's pretty easy after that. Does anybody disagree with that? It's okay if you do. You know, it's good for you, Mr. Mathman. Somebody with that? Yes. All right. So what's this square? FOIL this out. What do you get? FOIL this out. 1.
Minus 2, plus u.
And then just distribute the u squared in. Is that cool? All right, let me go ahead. U squared minus 2u to the 4th plus u to the 6th. What's the integral of u squared? U to the 3rd over 3, and u was cosine. So I just kind of skipped the step of, right? You know, you got to be careful. You might want to, at this step, go ahead and bring this in, right? Bring that negative in, just so you don't forget it. And then the integral of u to the 4th. Yeah, u to the 5th over 5, and u was cosine. And of course, I could write this as with a 5 there, doesn't matter. Blah, blah, blah. Is that all right? Then you got the 7th power, blah, blah, blah. Yes? Are you guys good? No? Okay. So this would be u7 over 7. So it'll be cosine 7 over 7 plus. There's no real reason why I wrote this differently. You could have put a 5 there. I just wrote it like that just because. Okay, maybe. How's that feel? Is that all right? I mean, the beautiful thing about sine, cosine stuff, I'll show you the worst it could get, which is not that bad. When you do have at least one of these is odd, you should go, oh, thank God. This is going to be easy shit. It's going to be a polynomial in u eventually. That's all it's going to be. Because you're going to use Pythagorean theorem. There could be other powers on it. What sucks is if this was the 3rd power, yes? That's the 3rd power there. Then you FOIL and FOIL. Which is just busy work, not hard, just, you know. Yes?
So problems like this are always going to be useful?
Yeah, they could be. Again, if one of these is odd, yes. If neither one of them is odd, we get a problem. Why is that? Because what is it about this being odd that kind of got everything rolling? This is odd. I had an extra sign. It tells me what u needs to be beautiful. So if neither one of them is odd, again, what's important about odd versus even when I'm talking about sine and cosine? All the Pythagorean identities have squares in them, right? Does that kind of make sense?
Yeah.
So that's why I don't want to, if they're both even, I've got a problem. I don't want to take anything away from it because that would take it away from the Pythagorean identity. That's why I need an extra one, an odd man out, to be able to get things started. So what I've given you on this sheet down here is a little box telling you, but don't memorize this box. It's sort of like a nice reference, but just understand why these make sense. Whoever's the odd guy has an extra one. Okay, that gets things rolling. If neither one of them is odd, that's what we have to try to do next. Yeah. Sorry? Oh, you need one? What edition do you So it might be a difference on the online version. Well, it's supposed to be the same, but. So just use the page numbers to get you close. Sort of like GPS. Okay. What was I about to do? Oh. So. What if I had this here? You're gonna love this. Okay. So who remembers sine squared x?
Was 1 minus cosine squared?
1 minus cosine.
2x.
So that's the nice thing about a lot of trig stuff is once you know the format of one thing, it sort of informs you about the format of the other thing. Cosine squared will be 1 plus cosine 2x over 2. And again, you guys agree that integrating something that's not squared is easier than integrating something squared in general? Okay, maybe? Okay. And real quick, can you guys tell me why this answer is not this? I get this all the time. Yes.
Because we don't have the derivative for sine.
Yes. You can't directly integrate something that hadn't come directly from a known derivative, right? I can't. Okay, so wouldn't this involve chain rule? If I took the derivative of this to check my work, wouldn't that involve chain rule?
Yeah.
And sometimes people lose that because they see the 5 here, but sine to the 5th x means sine x to the 5th. So what is the derivative of this?
5 sine to the 4th.
Shit, right? So I can't do that, right? Okay, maybe. So that's why this is definitely not true. Okay, so be careful about oversimplifying the idea behind an integral. Integrals, unless there's something really straightforward, they almost always will be a lot more difficult. If the derivative of this is difficult, the integral should be even more difficult in general, not always. Okay, so that's definitely not the way to go. But we know this. So how do I rewrite this?
Sine squared x squared. Right?
Yeah, good, I like it. So this is sine squared x squared. So then I get the integral of
Squared.
oh man. I love this shit. Let me help you out a little bit. What's kind of like the worst part of that? The fact that there's a what kind of hanging around with this stuff.
The exponent.
Not well. I agree with you. The exponent. So if that wasn't there, this would so be awesome. But this, right? So can I just square that and take it out? It's just freaking constant, right? What's 1/2 squared? Yeah. So now I can just worry about squaring 1 minus cosine 2x. That looks a lot better, yeah? Is that good?
Yeah.
So that's a little thing, right? But it's gonna affect a lot of integrals and stuff that we look at. We're desperately trying to get the numbers out the freaking way. Don't let them mess us up. Okay. And of course I gotta FOIL it now. No. You're in Calc 2, which tells me you should have developed some what I call mathematical stamina. So stamina, right? The normal stamina, right? You're able to withstand doing something like walking somewhere for a while. In mathematics, mathematical stamina means you can handle just continuing to do stuff. The problem isn't done yet, right? Do you understand what's about to happen here? What was it that told us we had to do this? What if that would have been a squared? Wouldn't I still have to do that, but it would have been one step and I would have been done? Do you guys see how I'm going to get another squared trig? I'm going to have to use another. Yes. Try to take this the next couple steps, and then I'll catch up to you. So foil this. See where you can go. You're going to have one piece of it you won't be able to do. You'll have to use another power reduction. Just to remind you guys. So for right now, just foil that thing out. And if you're not sure where to go from there, just hang out for a bit. Can somebody remind me why this specific problem is much harder than the ones we did earlier with sines and cosines? Why was the last one so much easier than this? Because there was a piece in there that had an odd power. The only trig function in here does not have an odd power. Damn. Okay. So what do you get here? Foil this out. So the integral of 1, it's pretty good. The integral of this should be easy. We'll see in a minute if you agree. The integral of this is going to involve some more work, right? So let's see. What's the integral of 1? X, 11. And let me put a 1/4. What's the integral of 2 cosine 2x? Yeah, so it'll be sine 2x. The 2's there, see? It's just sine 2x. Right? See how the inside is linear? Yes, the inside is linear, which means it should be easy to do. Cosine goes to sine. If I take the derivative, there should be a 2. There is a 2. I'm done. Yay, next. Right? If that wasn't there, then we would have done what? Divided by 2, because there's not supposed to be 2. I got to kill the 2 when it wants to come out. Do you guys understand that? Don't overuse u sub. I'm trying to get you guys to understand. When the inside is linear, you do not need u sub. You can make constants do what you want them to. We made them do my will. Okay. Sorry. All right. And then finally, we got this thing, which I'm just going to write like this. I got to remember my 1/4. You guys excited? We're not done yet, right? Oh. Okay, so let me focus on just this, and then we'll throw it in there and be done with it. So we just got to finish that one up, right? Nothing wrong with doing your homework this way either, as long as you do it and then bring it back. So, if I do 1/4 integral uh-oh. Too well. Come here, Red. Okay. So how do I rewrite that? If it's cosine squared x, it's 1 plus cosine 2x over 2. So whatever's here, what goes here? Double. Okay. So what's cosine squared 2x? It's going to be 1 plus cosine 4x. I love it. So the 2 I can bring out, make that an 8. Whoop. Is that cool?
Yeah.
Don't you hate it when teachers do that? So I want to rewrite this thing over and over. And now it's relatively straightforward, right? What's the integral of 1? X. And what's the integral of cosine 4x? It wants to be sine, right?
4x over 4.
Yes, because the derivative of this would have a 4 come out, it's not there, so it's got to be an over 4, so it kills the 4 that wants to come out. And again, if you really need to, you can use u sub, but dear God, get past that. If the inside's linear, you do not need u sub's help. You just think, what would chain rule need? It's not there, so it must have had an over 4 to kill it. And then I can just put that there, and I'm done. Well, you know, make this 1/32, right? Is that cool? Or is that understood, maybe? Maybe cool is going too far.
It's understood.
All right. And again, I need you to tease out the part that's busy work. My God, I would never give you a freaking 8th power here. Do you understand? Can you imagine if that was 8th power? Right? And that's really what that one problem gets to about the power reduction problem. It just sort of gives you a general way to kind of do it. But if I'm going to have you do it like this is probably the most I'm going to do to you. Can't speak for the homework. Homework might go further. We'll see. Okay, so again, the answer will be 1/4 x minus 1/4 sine 2x plus 1/8 x plus 1/32 sine 4x plus c. Right? Obviously, we knew it was going to be. No, we didn't. Yes.
How can you get the 1/8?
Over here?
Yeah.
Oh, I'm sorry. So, I kind of did this. Remember, there's an over 2?
Yeah.
And then I just pulled that out. If I pull a 1/2 out and it goes with a 1/4, it becomes 1/8. Right? No? What's that? So, if I take a 1/2 out and put it out here.
Oh, okay.
Yeah, okay. All right, I like it. Not too bad, right? What do you guys think about that? That's the worst sine and cosine can do, is if you have sines and cosines and neither one has an odd power. So if you had sine squared, cosine squared, do you see how it'd be a lot like this? You'd have to replace sine squared and cosine squared, and then you would FOIL these. You would multiply those out. Do you guys see that? I was thinking about doing that, but I think it's in the homework, so I'm going to let you guys do it. Okay, maybe. Okay. Now, I'm going to resolve this, but I want to give you a chance. Has everybody got all this stuff? Okay. Let's see. So here, do this one really quick. want something for later. Yeah, careful, no. 1 minus cosine 2x. Yeah, might as well bring that out there, right? Yeah, and then it's not too bad from there. Maybe.
1/2 x. 1/2 x.
Could be.
Probably, yeah.
Integral 1?
X.
X. And integral of cosine 2x? So that'd be 1/2 x minus 1/4 sine 2x. We'll see. Yeah, be really careful with your, make sure they don't look like exponents if they're not supposed to be. Yes?
Do you want us to always distribute the 1/2?
Yeah. You know, really simple stuff you should do. Yeah. So a lot of people just integrate and stop, and I'm like, well, there's so much you can simplify. Just go ahead and simplify that stuff, yeah. Okay. Not too bad, right? So that's the worst thing about sine, cosine integrals is you got to memorize that power reduction formula for the square. Okay. That one homework problem, just do it. You don't have to memorize it. It's just there, just to show you, hey, look at the weird shit we can do. Okay. So let's talk about tangent and secant. So help me out here. What is the derivative of secant? Yeah. And what's the derivative of tangent? Secant squared. So remember, we're basically doing u sub stuff. So we're trying to figure out, I want to make something a u whose derivative is in there. So for example, let's start off really, 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 really nice. And the funny thing is, I'm going to do this 2 different ways. This is really, really crazy straightforward. Is there a function in there whose derivative is in there also?
Yeah.
What is it?
Tangent.
Tangent. So of course that means I'm going to let u equal tangent. du is
Secant squared.
squared. So this becomes the integral of u du. Okay, that's silly. The integral of u is 1/2 u squared, and u is tangent, so you get 1/2 tangent squared. Right? Is that all right? There's another way I could do this specific integral. Remind me, what's the derivative of secant? Do you see how there's a secant and there's a separate secant tangent? Oh shit. So I could actually, and again, this is not me telling you have to do every integral twice. That's not what I'm saying. This is not me saying if you see this integral, you have to do it both ways. You have to do it this way. No, I'm just pointing out there are multiple ways to do this one. You can pick whichever way. So if I let u equal secant, du is secant tangent. So one of these goes with this and becomes du, and the other one is tangent secant, and that's u. Sorry. One secant becomes u, and tangent secant dx becomes du. There it is, Jeff. This looks the same, right? But, so the integral of u is 1/2 u squared. Let me do it the same way I did it before. And u was secant, so now I get this. Is that the same answer we got before?
No.
Interesting. So it's got to be though, right? On one level, it's got to be. So when you said it's not the same answer as before, you meant on the surface, it isn't. Of course, how are tangent squared and secant squared related? What is secant squared in terms of tangent squared? 1 plus tangent squared, right? Okay, so then you get 1/2 plus tangent squared x over 2 plus c. Is that the same as that? Is this the same as that?
No.
why not?
So 1/2.
This is a 1/2.
So why then is it actually the same? Because what does C mean? So can't I just wrap this up into this? So these C's aren't the same, but if I add 1/2 and C and I get another constant, it's the same thing. I really want you guys all see that. One reason I want to do that right now to you is you're going to pick a way to do an integral. The book is going to have picked another way. And you're going to check your answer and go, what? They just picked another way. There's probably identities that would put the two together. Do you guys understand? Am I saying every time you get a different answer, it's probably right? No. But I want you to understand, you could do a problem completely right. The book just chose a different route. So you got to be really careful when you check your answers. They could be the same. Okay. They're not always immediately as obvious as this that they're the same. Yes?
So the 1/2 is just added to the constant?
Yes.
Okay.
Anytime is this plus C
Yeah.
the same plus C as the first integral you ever did in Math 180? Is every plus C the same that you've ever done? What do you guys think when I say that? What tells me what the C is? Other information. They have to tell me some kind of at 0 the value is 7. Now I can figure out what C is, yes?
Mm-hmm.
So every C you've ever written is not necessarily the same as every other C, right?
Right.
So in this case, that C is equal to this guy plus 1/2.
Okay.
They're still constants, correct? Okay. I don't want to make too big of a deal out of this, but that's a little tiny thing. When I write a plus C, I'm just wrapping all the constants into one C. Over here, I chose a different way, so not all the constants were wrapped up yet. That's all. These are effectively the same exact answer. Just the value of C here is different from the value of C there. The value of C here is 1/2 less than the value of C there. You guys agree?
Mm-hmm.
Okay. If anybody's going to take differential equations, anybody? Your plus C's are going to become crazy important. You're going to have to keep track. There's going to be a plus C1 and a plus C2 and a plus C3 and a plus C4. Just something to look forward to. So, I love diffie-q, by the way, and of course I will. Okay. So that was nice because I could show you both possibilities. Okay. So let's do another one and see which way you think I should do it. Let's see. Yeah, let's do. Well, that's too easy. Let's see. So you've only got really two things you could do, right? U is secant or U is tangent. I'd be really honest. In some situations, there could be more you could do, but right now we're just looking U is secant or U is tangent, correct? So if you're not sure, you could kind of try each. Now, what I gave you on this paper, maybe don't look at it yet. I try to kind of give you ideas depending on which thing is even and which thing is odd. Okay, so let's just look at this. What do you guys want to try? Let U equal what? Secant. You wouldn't want it, if you make it secant squared, what's the derivative of secant squared?
Just secant.
2 secant, secant tangent.
Right.
We'd have a chain rule, yes? That's what I'm saying. In general, U is secant or U is tangent. So if I want U to be secant, du is secant and tangent. So let's see what this entails. Okay, so how do I kind of investigate this? I need one secant to be over there. I'm sorry. I need a secant and a tangent to be over there. There you go, John. So my du's got to be able to show up, right? So I pull a tangent off and I pull a secant off. Now, this would just be u cubed, correct? Why does this tell me I'm on the right track, that this will work? Because, go ahead, sorry.
One is odd, one is even.
True, but just focus on the fact that it's tangent to the fourth, that there's an even power in tangent. What is u again on this? What did we decide u was? Secant. So what do I want to rewrite this in terms of? Secant. And the only way I could do that is through the Pythagorean identity, which has even powers in it, yes?
Yeah.
So isn't this tangent squared squared?
Yeah.
Good Lord, man. All right. Yeah. So this is du. What's this?
Cubed.
U cubed. And tangent squared is?
Secant squared x minus.
Secant squared minus 1. I love it. So this will be secant squared x minus 1, which is u squared minus 1 squared. Oh my god, everything's so freaking off kilter. This is better. There we go. That's du. Let me stop for a minute. Do you guys understand that if this would have been 6th power, right here this would have been 5th power, I would have seen that that was the wrong way to go, I would have backed up and chose the other way. Is that a big deal? No, not a big deal at all. In fact, it's beautiful. It's exactly what we're supposed to do. And I'm not going to do this. Is that all right? Is that, this is just polynomial. Is that okay? You guys okay with me not doing this? No? You're all like, whatever, man, you're the teacher. Foil it, distribute, integrate, polynomial, put the secant back in. Okay, right? Yes? Is that all right? Okay. Now, with all that said, I have tried to capture for you. Look at the bottom of this page. If the power on tangent is even, I'm sorry, the power on tangent's odd like it is here, you could let u equal tangent. If the power of secant is even, you could let u equal secant. So this is another example of a problem that would work either way. Do you have to memorize this? No. But you can if you want to, right? You totally can. Okay. So the thing I'm trying to work on over here, which I might just, well, I can't do that, shoot. Let me give you guys a problem to try, and while you guys are doing that, I'll work on this. So you can make one that's not too crazy. Let's see. Yeah, okay. Yeah, okay. So I guess do that. Let me see if I can get this here to work. Boom, bam, bam, bam. Bam, 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 bam. Sorry? Plus, that'll work. Same thing, okay. using your little paper to help you out, you'll see basically gave you the same situation. So either thing you pick should work. I'm curious, I want to see if somebody picked one way or somebody picked the other way. So I'm going to do this way.
I got the same thing I did it the other way. So.
Okay. Yeah, that's going to happen a lot here because of the way that secant and tangent are both related. That's what I got. I'm assuming a lot of you guys probably started with tangent, maybe?
Yeah.
Right? So if you started with tangent, let's see. Which means you'll want to shuck off a couple of these to be your du, right? So I can kind of plan ahead. If I want u to be tangent, I know what I want du to be. So that makes this will be u cubed. What's this? Yes, u squared plus 1, because secant squared is equal to tangent squared plus 1. Right? So slight difference there, see? Where am I? That's du, so then you get integral u5 plus u cubed du. So you get tangent 6 over 6 plus tangent 4 over 4 plus c. Now, are these obviously related?
Wait, why is it not?
Sorry?
Why is it u squared plus 1 and then
Ah,
the other one's u squared
because
minus 1?
what's secant squared equal to? What's tangent squared x plus 1?
Makes sense.
What is tangent squared x plus 1?
Secant squared.
Yes. So I can replace secant squared with tangent squared plus 1. U is tangent, so that's u squared plus 1. Is that all right? And again, if it isn't okay, tell me. Because I am sort of skipping a couple things. I'm not writing every single thing down. So right here, I'm skipping writing, let me write it above. Secant squared is, by definition, tangent squared plus 1. Tangent is u, so that is u squared plus 1. Okay. But don't let me do that, and then you're not sure what I meant in the middle. Just say, hey, Jeff, real quick, how did you get... Not a problem. Okay. Yes?
Yeah, if you could write that out, that would help.
Yeah, so right here, right? Secant squared is tangent squared x plus 1. So now I got my u is tangent, so that's u cubed. U is tangent, so that's u squared plus 1. Du is secant squared, so that's du. So the only thing I left out was that. Yeah. Okay, I like it. Now these are not as obvious to rewrite in terms of each other, but the thing about secant and tangent is they're intimately related with the Pythagorean identity. So you could actually rewrite this to look like that or vice versa. It just wouldn't be as nice. So the answers will not always be obvious that what you got and what the book got are the same. Okay, maybe. What's one way you can check? Take the derivative of what you got. See, that's the same. Yeah. Okay. All right. How you feeling about that at the moment? A little worse than sine cosine. This happens. It just means it's growing. It's just like muscle pain. Thinky pain happens, right? And if any of you guys know Mark Maron, the comedian, Thinky Pain? No. He's a great comedian. Sine and cosine, it makes sense that their rules very straightforward because they're directly related. Sine is cosine is negative sine, blah, 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 right? Or the other way around with it. So they should be really easy to put together. Secant, tangent, one is the square of the other one, the derivative, and the other one is itself times the other guy with the derivative, holy shit. So it's not going to be as perfect, but they are very related to each other. Here's something that really sucks. Okay. By the way, this is my note to myself as to how to do what I'm about to do. I always have to redo it so I can remember what it is. What if I had to do this? On first glance, you're like, okay, right? And then you start to think about it. And the pain comes in. Right? Or I don't know. Some of you guys might have seen how to do this. I don't know. Has anybody seen how to do this and remembers? Okay. Yes?
Do we run over cosine?
Sure, let's try it. Let's try and do some shit, right? That's what we're all about. So the thing with calculus is we just keep expanding our toolbox of all the stuff we can do to integrals. Give me an integral. Let me see what I got. I got this and I got this, right? So what do we know so far? Straight up integrals that we're just lucky that are exactly antiderivatives of something, yes? U sub, my parts. Our toolbox is big and empty just about. We got a few things in there, right? So let's try some shit. So I love it. Let's try good old trig identity, right? Gonna use the U sub. Can I use the my parts? Can I use something? No, real quick. So that, do you see how that's not gonna get us anywhere? Not a damn bad idea. It's a beautiful idea. You write it down, you go, oh, that got me nowhere. Right? Remember how we did this? Can you integrate natural log? Now you can, but at first you couldn't, correct? So then we did it by parts, and since we can't integrate it, what did I make natural log equal? U, because then I can differentiate it, right? So let's try that. Let's try, let's let U equal secant. And then what's dv?
1.
No, sorry.
dx.
dv is dx, good. So then du is secant x tangent x. And then v is x. So then I get uv minus the integral of v d. That sucks, yes? That sucks. That sucks. That sucks on so many levels because that's the ultimate tool I have at the moment. Right? And I don't know how you guys feel about it. Some of you guys hopefully are like, yes, give me some more tools. Some of you guys are like, no, it's okay, man. Okay, hopefully most of you are like, give me some more tools. This one is not a tool. It's a, which is a funny thing to say. I don't know. He's not a tool, she's not. This one is, I can't use a tool for this. I have to use something really weird. Okay, help me out real quick. And you've seen this before if your teacher showed you the proof for product rule, for example. Nobody here took my 180, so I can't speak to it because I show my students the proof for product rule. Remember product rule? Remember those days?
Yeah.
Remember thinking that was hard? Okay, did any of your teachers show you the proof of that, do you think? I used limit definition of derivative to show the proof of that thing. Oh, holy shit. So, a lot of times in mathematics, we have to add and subtract something to be able to do something bigger with it. In this case, I'm going to multiply, divide by something. Can somebody help me out? What's the derivative of this expression? What's the derivative of this?
Squared plus.
Now notice this. Can you factor what you just got?
Yeah.
What factors out?
Secant. Secant. Plus tangent.
Isn't this the same thing? So watch what that means. Watch what that means. If I multiply top and bottom of this by this, I can let u equal the bottom, which will be this, and then du will be the top. Holy shit. Now that is something that I would not put on a test and go, let's see if they so evil, because it's such a weird thing to do. Yes? Who would think to do that besides all these weird ass math people that had a candle and no YouTube and they're like, all I gotta do is just do shit with these integrals. Let me just, that's how we get through the day, right? Sorry, can't watch the funky YouTube videos. I'm just gonna play around with integrals. So if I multiply top and bottom of this by, in fact, let me just be really, so I'm gonna do secant x over 1 and times tangent x plus secant x over tangent x plus secant x. Okay, so on the top I get secant tangent plus secant squared. Is that cool? My God, if I could write, everything would be so much better. Over, and out there somebody should have said, you got that right. All right. So, weird. Who would think to do that? That looks so much worse than it did. Until you realize, like we did, if I let u equal the bottom, what's du? The top, right?
Secant squared
Secant squared
plus tangent.
plus tangent x secant x, which is the top. So I get, this is the integral of du over u. And what's that?
ln.
Yes, ln.
ln u.
Careful.
Oh,
Absolute value. And what was u?
Tangent x plus secant.
So the integral of secant x is this funky, out of nowhere thing. Plus c. Okay. And it used a process that just kind of came out of nowhere, but so many times in mathematics, like when I was taking math courses, you start to develop a list of things that are equivalent to 1. Because when can you multiply by 1? Anytime, right? So do you understand? We just multiply by 1, correct? But this wouldn't be on my list because it's a very specific situation. There are certain things that are equivalent to 1 that you can use a lot of places. So it's good to have a list of things that are equivalent to 1, because then I can just multiply by it and maybe it does something like this. So this happens a lot in mathematics. Not like, algebra level very often, but, it happens a lot after that. Okay. So this is just a known fact now for us. You guys with me? Just a known fact. If I want to do integral cosecant, couldn't I do something very similar? I would do something almost exactly the same. Yes? Okay. I think, I can't remember in the homework, there might be one of these. So, let's see if that shows up. And then you build it off of this. So write this down somewhere. Keep track of this. Okay. So, last thing I want to do today. So we just finished up section 7.2. Right? We're going to get a little bit into 7.3. 7.3 is one of my, I love 7.3. And I don't know how that makes you feel when I say that. I'm going to erase all this stuff. So I want to start off with something that seems not related to calculus at all. Isn't that nice? Let's say I have this. I just have this expression, right? Okay. So we're going to take a little trip back. There's no calculus here for just a couple minutes, right? Okay. Give your brain time to heal itself. Right? Hopefully, let's see what happens. Can you guys just take a minute and figure out what that is? Don't say anything out loud, just try to figure it out. Nothing major there, you guys with me? All that's doing is just plug that shit in. And can you simplify it? That's the question. Go ahead and try. So I'm just plugging that in there.
Is this theta?
Yep. Good old theta. Alright, let me catch up to you guys. You should be able to simplify it a bit. 9 minus, what's x squared? 9 sine squared. Good. What can you do to that? Please, your God, don't tell me the answer is 3 minus 3 sine theta. Make me cry.
Just factor out the 9.
Beautiful. Factor out a 9. Somebody said that's what they said. Real quick. Square root of x squared plus 4 is not x plus 2. Holy shit. Yes? No. Yes? Right? I like the way some of you guys are looking at that. You're looking at it like this. Beautiful. Some of you guys are looking at it like, what's wrong with that shit? Yes, you can't distribute a square root across a plus. The square root is like a power. Powers don't distribute across addition because they're based on multiplication, not addition. Bam. Right? Okay. Maybe? So don't square root each piece and go magic. No. What's the square root of 9? Holy shit. And what's 1 minus sine squared? Cosine squared. Now, here's where things happen. One little thing on the side here. I'm effectively saying this is true, right? Is that cool? I'm replacing x with 3 sine theta. Which means, if I want to know what theta was, I'd have to do an inverse sign on that. Is that cool? Right? And what is the range of inverse sign? Who remembers?
-1.
No, that's the that's the
Negative
domain.
Pi over 2 to pi over 2?
Negative pi over 2 to pi over 2.
Yeah.
Yes. And the way to remember that, oh shit, this is a major memory to dredge up, yes? Are you good? Okay. Do you remember, so here's sine. What sucks about sine in terms of taking an inverse? Automatically, what's wrong with it? If I want to take an inverse of sine, why can't I? What do you have to do to be able to take an inverse of a function? It's got to be what kind of function? It's got to pass what kind of test? What's it got to do to pass to be a function? It's got to pass the vertical line test. To pass to be an invertible function, since I would flip it, instead of flipping it, I flip the test. So it's got to pass the horizontal line test, right? So I could flip it and then check to see if it's a function, or I could just go, holy shit, let me just do a horizontal line test on the original. That's where that HLT came from. So we have to do this to it then, don't we? From negative pi over 2 to pi over 2. That's why, do you remember doing, oh boy, here comes the memory. Do you remember solving triangles in pre-calculus, and the sine ones sometimes ended up with 0, 1, or 2 answers? Anybody? That's because the inverse sine gives you a reference angle. It could be in the second quadrant instead of the first or something. So inverse sine, when you do it, it can only give you angles from the fourth quadrant to the first. So if your angle is supposed to be in the second quadrant, oh shit, you better add some stuff onto it to make it in the third quadrant, or the second quadrant, wherever it needs to be. Do you guys remember this stuff? Yes? You're good? Okay. So here, in those, what's true about cosine in the fourth and first quadrant?
They're positive.
It's always positive. So what's the square root of cosine squared then? Yeah, I don't need an absolute value. You guys with me? I want all this to connect, because when I learned this, I wasn't explained it to me that way, and I was like, why are we not putting absolute values? Why are we not putting plus or minus? Why are we not doing? But that's why. In order for this to make sense, inverse sine has to be true, so that's the angle has to be there, which means cosine is positive, which means I don't need an absolute value. Okay. All right. So I could do a couple of different things. And by the way, if I tried to use tangent here, would that have done as nice? If I use tangent here, wouldn't this have been 1 minus tangent squared? Is there any identity 1 minus tangent squared? No. This is important. What we're about to do is we're about to get into a realm of iteration where we use what's called trig substitution. So we're actually going to make this substitution for x. And then we can do dx, which would be in this case 3 cosine theta. And we can do shit to it. And believe it or not, it feels like we're making it worse, right? When actually we're making it possible. Okay. So, let me see if you guys can answer it this way. What substitution would make sense? Whoa. I thought somebody was like, I'm done with this shit. What substitution would make sense in here? I want a trig substitution, so I end up with something I can use one of the 3 basic identities on. So the way you think about it is, see this? It's basically number minus function squared, yes? So 1 minus sine squared, that's why I made it sine. What's related to function squared minus number? Secant. What's secant squared minus 1? Tangent squared, right? So if I now let's see if you guys can really piece this together. I can't let x equal secant. That's not good enough. It's got to be 2 secants, so that I will be able to take a 4 out. Do you guys see that?
Yeah.
Let that make all the sense in the world. You're not guessing at what to use. You're looking at the form it's in, and you pick the trig function that matches that form. That means you have to know your freaking Pythagorean identities, right? Or else you ain't got nothing to back this on. Okay, so what happens here? So we get x squared will be
4 secant
Yeah,
squared
4 secant squared. So I can take a 4 out. Is that cool? Secant squared minus 1 is tangent squared. Tangent squared is tangent. No. There, okay. Right? Maybe? Okay. Yes?
Can you explain why you put 2 secant theta?
So, we know this, right? True? We know this, right? And we know this. Do you see how the form of this? Function squared minus number. Function squared minus, it must be secant. Is it a 1 there, though? It's a 4. So I need the 2, so when I square it, I can get the 4 the hell out the way, and there will be a 1 left. I am desperately trying to show you why these substitutions make sense, not just memorize the damn substitutions, which you can do, right? Okay, maybe. All right, let's actually bring some calculus in now. Will there be any calculus in this calculus?
So
class?
with
Yes.
the trig substitution will always be related to Pythagorean?
Yes.
Oh, okay, nice.
Now, I gotta be careful. I mean, much later in your studies, you could do some for what's concerning to us in this class? Yes.
Great.
Always. Okay. That's how it should always answer. Yeah, it's just, yes, for us, no, yes. Okay, so this is gonna be exciting. I'm gonna make a problem that can always be, see what happens with this problem. This problem could lead us to weird places, so let's just see what happens. Let's see, what have I not done yet? I guess I haven't done that one. This is where things could get weird. All right, let's just make it nice. Okay, let's all hope that things go okay. Now, real quick, let me make sure you guys know what that is. Is this a U sub problem? Could I do this with U sub?
Yes.
No. Sorry. If you let u equal this, then x squared equals u minus 4, but then you don't have an x left over for the du. Does everybody follow what I just said? If u is this, I need a 2x. And that means I can't leave an x squared. That way I would be able to replace with a u. Oh, shit, right? Is it by parts? Do you want it to be by parts? Okay, all right. By parts would really suck on this. Yes, it would. It would suck so bad. So, trig sub, do you guys pick up on the fact that trig sub, not always, but most of the time will be radical, number plus or minus x squared, that kind of thing. That's what it's gonna mostly look like, all right? Some of you guys might understand there will be later problems in the homework where you might have to do something like complete the square. Shit. All right, or something related to that, right? Okay, so let's try this. Can you look at the form of this and tell me which trig function it makes sense to use? Trig squared plus a number. Yeah, tangent, right? Do you guys understand how to tell? You don't have to memorize it. If you know those, why memorize more shit? Tangent squared plus number is related to a trig identity. So that's what we're going to use. Now, what am I going to let x equal though? I need the 4 to be able to come out. 2. So then when I square it, I get a 4, so I can take a 4 out, right? So if that would have been 16, I would have made it 4 tangent. If that was a 5, I would have made it square root of 5 tangent, yes? Will that happen? Yes. Just whatever number's there, you put the square root of it here, so that after I square it, it'll match, right? Maybe.
Yes.
So, this will be 2 tangent, like you guys said. Right now, I can then do, what's x squared? I'll just do it right here.
4 tangent squared.
And what's dx?
Oh. 2 secant squared.
One nice thing about trig sub is it's already solved for dx. Do you guys see that? Like the dx is just a substitution, not something you have to manipulate, right? So let's do everything here. So what goes here is x squared. This is the square root of 4 plus 4 tangent squared. Dx is 2 secant squared theta d theta. Just substitution, right? This is very different from u sub, very different from trig, from biparts. We are actually replacing a letter with a function of a completely different variable, right? Feels weird. Okay. And this does not look great. Let's see where this goes. I can take an 8 out. In fact, what's the square root of 4? Let's see if you guys are cool with this. That's a factor of 2 times 4 is 8 times 2 is 16. I could take a 16 out. Tangent squared. What's 1 plus tangent squared? And square root of secant squared? Secant. And then there's another 2 secants. So I get secant cubed. Become a square. Now here's a situation. Let's see if you guys, if you want to, you can look at your sheet. You guys understand what kind of problem we just uncovered? What kind of problem is this? This is a problem from the previous section, right? So if I try to make a secant squared show up, I'm going to have a secant left. U is going to be tangent. I'm only going to have a secant. I won't be able to rewrite it in terms of, oh shit. If I try to make U secant, I'll take a tangent and a secant over. I'll have one tangent left. I can't rewrite that in terms of secant. Damn it. Right? Does it give us any help on that paper as to what to do when the power... It doesn't? Man, I'm so evil. The last thing is down there. If m is even, m is the power on secant. If m is even, oops. M is the power, thank you. If only I could see. If m is even and n is odd, what does it say to do? Powers of secant alone. So let's see what we can do. So I want only powers of secant. So this will be tangent squared would be 1, secant squared minus 1. Secant cubed. Yeah, this did come out grosser than I wanted it to. So secant to the 5th theta minus secant cubed theta. And then there's a whole, then there's actually power reduction for secant, which I'm not going to make you guys memorize, so don't worry about it. I knew if I try to make one up out of nowhere, it would end up in a gross place. But there are, I think I told you guys that integral secant cubed might be one of your problems from the last section. Yeah. So this is just a step up from that. Okay. So this is stuff that you would look up and replace it with. This is not very interesting. It got to a gross place. That's what I get for trying to make one up. Which really sucks. Okay, let's let go of that one for a minute. That one got to a gross place, and that was just me making one up on the fly. Let me see if I can get one. Does anybody got their physical book with them? No? Or is anybody able to access the book? Does anybody have a physical book? I don't even have a physical book, so I can't complain that much. Okay. Let's see if I can't. Let's do one. Yeah, let's do one that all right, let's do this. Oh, you got one? Okay, thank you. I just want to be more safe. If I try to make a problem up out of nowhere, weird things happen. So we're just going to take one right out of here. Oh, Jesus. Okay. Don't get old, kids. All right, all right. Yeah, let's do x squared. Okay. Yeah, okay. Lord. Okay, so let's try this one, because there's a little bit extra stuff. This will be the last problem we do today, I think. I'm going to let us out here a little early. I keep saying don't get used to that. We'll see if that actually, all right. So help me out. Could you use U sub on this?
No.
Hell no. What about by parts? Would you like to use by parts on this?
No.
No. Okay. What tells you this makes sense to be a possible trig sub? Because it's got that 9 minus x squared. It doesn't have to be under a radical, but most often you'll see it under a radical. That'll be a trig sub problem. Now, real quick, if that was this, what would I do? U sub. Trig sub would work, but why, right? But there, oh shit, okay. So somebody, think about it for just a minute. Don't say anything yet. What would my substitution be? Don't say anything. Which identity does this relate to?
That's sine cosine.
Sine cosine, right?
Yeah.
Constant minus trig squared. That's 1 minus sine squared. Is cosine squared. So I want to let x be something sine. What do I want x equal what sine? 3. So it's really the square root of whatever that number is, right? If there was like a 4 in front of the x squared, you have to factor a 4 out first. There must be a 1 here. So there will be some of the homework, you just gotta factor the damn thing out of the way. Okay. Y'all look appropriately excited about that, okay. So here I can do a couple things. I can figure out what x squared is. You don't have to. And then what's dx?
3 cosine. Cosine theta, cosine
D theta. Don't forget your d theta, okay.
theta.
In fact, do you see how if you're not in the if you don't write this down, you might forget to substitute for it entirely? That's a huge mistake I see that people make. So, integration does not make sense unless both of these are present. They're like bookends. They're like a bookend symbol. They both have to go together. So let's see what we get when we replace stuff. X squared is 9 sine squared. Dx is 3 cosine theta d theta. Yeah, so I get square root of 9 minus 9 sine squared theta. Okay, so then I get, let's see, I get 27 over 3, is that cool? Right, I can take a 3 out, square root of 9, so I can take a 3 out, it actually cancels, so I just get a 9 out front, is that cool? I do skip steps, I'm sorry, so just tell me if you're not sure where things came from.
Explain where, because I see where the 3 comes out.
Yeah, a 3, square root of 9 is 3, that cancels with that 3,
Right.
so then I can take this 9 out. That's the only number left to left. On the top I get sine squared cosine. And what is the square root? See, I took a 3 out, so what's the square root of 1 minus sine squared?
1 minus sine.
Yeah, cosine squared, so square root is cosine. And that kicks a lot of ass, yes? You guys agree with me?
Yes.
That's a lot better than this weird shit? Okay. And now, again, it kind of makes sense that a decent number of your problems in this section are going to end up going back to the previous section because you're putting sines and cosines and shit in there, so, and secants and tangents and stuff, so of course it's going to possibly. So, do you remember how to integrate sine squared? How do I have to rewrite that?
Minus cosine 2x, so it's
Careful, 1 minus cosine,
2x.
yes.
Times
No, 1 minus cosine twice theta over 2, I'll just put that out there. It's going to make my integral look all weird. Alright, so then integral of 1 d theta is theta. Integral of cosine 2 theta wants to be sine.
Sine 2 theta over 2.
Good, gotta kill the 2 that would want to come out. Yes, maybe, is that right? If I just do this, the derivative would have a 2 here, there is no 2 there, so there must have been a divided by 2 to kill that 2. Pussy! Now, what's wrong with this answer? Sorry. You know, like, oh, what do you mean? There's nothing wrong with that answer where it is, but that's the wrong thing to circle. What was the original question?
X's.
X's, oh shit, right? And I've given an answer with thetas. Whoever had this problem doesn't give a shit about it. Doesn't even know what the hell's theta. What are you talking about? I had X's. What have you done to my stuff? Right? I dropped off pants, and you give me back a coat? What? Sorry. Okay. Some dry cleaning. All right. Right here. Can somebody tell me what theta is based on that statement by itself? What's theta? X over 3, and then I take an inverse sine. Is that cool? If I want to solve for theta, I got to take an inverse sine. Okay. I pretend like I did it on purpose. People at home. So I know what this is. That's inverse sine. Where'd it go? X over 3. What about this? watch this. This is so cool. If I go back one step, isn't sine theta equal to x over 3? Yes? Right? Is that cool? Can't I draw a triangle? Now, what's wrong with that? I know information about theta, don't I? I know everything about theta. I do. What does this need? Do I know a thing about the angle 2 theta? I don't know shit about it. But I know sine theta. Now listen, real quick. I want you on board with me about what we're going to have to do over there. If sine theta is x over 3, can you tell me what cosine theta would be? Can't you make a triangle? Which side is x because it's sine? Opposite, sure. The y piece is going to be what's on top. And 3 is the hypotenuse. Is that cool? How do I figure out what the cosine is? Yes? Hypotenuse squared minus this squared, so it'd be 9 minus x squared. Does that look at all familiar? Maybe? Oh, okay. Why am I doing this? Anybody remember what sine 2 theta is in terms of theta? The double angle formula? Yeah, 2 sine theta cosine theta. Don't I know what sine theta is? What's sine theta? And what's cosine theta? Square root of 9 minus x squared over 3? Yes? Over 2, so that should just kill that. Let's just kill that. Die. And then I could just make that 9, who cares, right? Is that right? I need one more parenthesis. The thing I want you to get from this, by the way, real quick, any problem we do on the board, that specific problem doesn't mean anything. It's what we do in it. Because am I going to give you this problem on the test or a quiz? Hell no. We already did this problem. I'm going to give you this problem. So what's important in any problem we do is why we did each step we did, right? So I can't stop here because it freaking needs to know what x stuff is. Okay, shit. So I got to go back and say, what is the relationship between theta and x? Well, that's the very first thing I did. I automatically gives me a relationship. And the thing people forget is, if you've got this, you can draw a triangle and get all the other freaking trig functions you want. Okay, maybe. That is gross, yes? Can you imagine trying to get this answer before you knew trig sub? Look at this answer right here. Oh my God. Okay. So let me give you this. I have a handout, believe it or not. It kind of captures what we talked about. On the reverse side, I just don't like giving you one-sided paper. So that's 7-4 that we'll talk about later. Don't freak out. Sure. All right, so you can see on this, I gave you kind of the reasoning that we talked about it. I reminded you about the range of the various inverse stuff. There are 3 problems. We'll do them next time. If you want to try them out in the meantime, you can. And the back, I don't know if anybody's ever seen partial fractions before. It's officially called partial fraction decomposition. So we let these big fractions decompose into their parts, right? Put them in a big pile in the corner and just wait. No? Okay. So we'll go over that. Even if you've never done it before, we'll just start from scratch. But next time we'll finish up trig sub. We'll have the quiz first thing. You know, I'll give about 10 minutes or so for questions before we do the quiz. If you miss a quiz, you have to let me know why, and then the next test will take the place of the missing quiz grade. So you just have a little more pressure on that test, right? Yes?
Will some trig sub be on the quiz?
No, the quiz is only on U sub and biparts. Yeah. I never quiz you on, or test you on something you learned the class before that. Yeah. All right, that's plenty. Come up and see me if you need to. Otherwise, I'll see you guys Wednesday.
I'm in the 289 class.
Oh, yeah.
class.
Yeah.
She wanted me to get your sign off on this, and then fix it and put what you said last class.
Yeah. Maybe change this into turn home again before.
Before, yeah.
Because you could be like, never turn home again. There you go. Okay, I like it. And you got Jenny's teaching that, right?
Yeah.
Yeah.
She's awesome.
That's awesome.
Thank you.
Okay, you're welcome. Hey.
Do the homework.